Welcome, my name is Nicoleta and I'm the Product Manager of the Performance Materials Division of Concentrol. In this online training, we are going to explain the definition and the basic notions about the release agents for molded polyurethane. When we speak of molded polyurethane, we always think in the first instance, and as essential, of isocyanates and their pre-polymers, eta or ester polyols. Also, we think about molds, high or low pressure injectors, polyol formulations, amines, metal salts, blowing agents, etc. But little is said about the use of mold release agents until the startup trials of the molding projects begin. A release agent is not necessary. It is essential since polyurethane cannot be molded without it. It acts by forming a barrier between the mold and the surface of the molded part. By this way, it helps to release the polyurethane from the mold, as its name suggests, but it also interacts with the polyurethane to a greater or lesser degree. We must take into account the high adhesion power that the polyurethane implies. In other words, without a release agent, the part adhered to both sides of the mold, bottom and lid, either splits or the mold cannot be opened. We can consider that the release agent is fed back from the increasingly sensitive polyurethane formulations. Its work is being each time more complex as well as the molded parts. In fact, when the pre-series start, all those involved in the release, operators and technicians, begins to see the influence and importance of the release agent on the appearance of the part produced. Also, on the rejection and repair of parts, and in general, on everything that depends on the demolded surface. Sometimes for better and sometimes for worse, the release agent is largely responsible for the appearance and the properties of the parts. This happens in all types of polyurethane foams or in compact polyurethane without internal cell. Among the properties that we can mention where the release agent is involved in, we can list the following one as an example, although many others are possible. In the case of seats, backrests and headrests, the release agent must give the surface a softening, sliding effect to facilitate the covering and the subsequent assembly. Also, it must give an open pore to be able to break the cell. Working with soundproofing for cars, the open pore is necessary so that the noise will be absorbed inside the foam. In the case for the polyurethane flexible HR foam, in general, it is important to avoid the appearance of bubbles due to underdrying or at excess temperature, both possibly given due to the release agent, although the formulation of the components may also cause it. In the production of flexible foam with integral skin, the surface finish of the part is inside, and there cannot be any material flows or any dragging. Moreover, in this type of parts, it is important to obtain the more or less glossy finish, depending on the requirements. Because it is feasible, the part should have total surface equality without any appreciable surface defects. Other properties where the release agent and the components may influence could be the touch, soft, rough, to avoid the noise of the mounted seat, to obtain an imitation leather plastic back finish, like for example rigid foam in continuous or discontinuous process that is used for the production of sandwich panels. Intended for thermal insulation, another property would be a slippery or non-slip effect. Waterproof properties, for example, in the intensified flexible parts. An adhesivity, for instance, applied to heating pads, motion sensors, which means that the residue of the release agent on the surface part must allow to stick a self-adhesive, among other applications and properties. After seeing the main properties, we should not forget about the physicochemical characteristics that differentiate the different types of release agents. We have the traditional flammable or combustible solvent-based ones. That will be always ATEX. By raising the flash point, the release agent may no longer be flammable, but it will remain combustible. By the other hand, we find the combinations of water and solvent as a vehicle in the hybrid formulations from 50-50 to 70-30 water and solvent. Co-solvents with less than 10% solvent participations, and finally the 100% water-based ones. There are also different application systems: air mix, airless, aerographic, and electrostatic spraying equipment, which may or may not be robotized. As you can see on the chart, to all this we add the possible risk of flammability, toxicity, VOCs, transport, storage, stability, and sternness of the product. And we also take into account the additional parameters that we have mentioned in this presentation, such as the degree of mold buildup when working, the adequate cleaning for each type of residue that remains in the mold, possible allergies depending on the raw materials used, and the sensitivity of the operators. Also, the applications in which food contact is required. Considering all the said before, we can affirm that release agents are complex products due to the multitude of possibilities that are available when formulating them, and also the multitude of properties expected from them. Taking into account all these parameters and the working system of each client, Concentrol adapts the optimal release agent for each line by designing formulations that will cover all their needs. Our team, made up of commercial and technical managers, as well as application technicians with a lot of experience accumulated at production lines, are the best guarantee of success in the implementation and optimization of custom release agents for polyurethane foam for any client that needs it. This was the first online seminar for release agents. See you in the next one.